Welcome back to the channel. Today, I'm starting with a completely blank DaVinci Resolve project. No media, no timeline, just an empty workspace. But with just a few clicks, boom, your media pool can be automatically populated. Pretty cool, right? Well, that's exactly what we'll be covering in this video. I've crafted a Python script that automates this setup for you, making your video editing workflow smoother and faster. But before we dive in, a small favor. I spent a lot of time planning, writing, testing, and optimizing these automation workflows. Please support the channel by subscribing. It really helps me keep creating more practical codes like this for DaVinci Resolve users. Why this automation matters. Now, you might be thinking, isn't adding media to the media pool simple enough to do manually? Sure it is, but this isn't just about one-time convenience. This is a foundation for a larger automation workflow that will save you hours in future projects. So trust me, this step matters. Stick with me. This is just the beginning. Before we dive into the actual automation code, let me first show you how this Python script can be used directly from the DaVinci Resolve workspace menu. If you're already comfortable running Python scripts to automate tasks in DaVinci Resolve, feel free to skip ahead to the next section, where we walk to the automation code itself. Let me demonstrate how my project folder appears under the Workspace Scripts Comp menu in DaVinci Resolve. Here's my project directory. It contains 4 files, 2 Python scripts and 2 configuration files. By default, especially in the free version of DaVinci Resolve, scripts cannot run from just any folder. The Python files must be placed in a specific directory. For Windows, that directory looks like this. But in my case, my scripts are located in a completely different folder. So, how is it working? Let's open the default DaVinci Resolve scripting folder. As you can see, it contains a shortcut pointing to my custom project directory. This isn't just any shortcut. It's called a symbolic link. This symbolic link effectively makes DaVinci Resolve treat my external folder as if it's part of its internal scripting directory. Now, you can create the symbolic link manually. I actually have another video that walks you through how to do that step by step. But today, I'm going to show you an even easier way to create it, using a Python script I wrote. To demonstrate, I'll first delete the existing symbolic link so that my project no longer appears under the Workspace Scripts Comp menu. Now, let's recreate the symbolic link using my helper script. The script is called symbolic_link_setup.py. I'll provide a download link to this script in the video description. You can reuse this script anytime you want to make a folder accessible from the DaVinci Resolve workspace menu. So, it's a good idea to keep a copy handy. For now, I'll copy it into my media pool automation folder. With the script in place, all we need to do is run it as administrator to create the symbolic link. There are multiple ways to do this on Windows, but here's one simple method. Make sure you are inside your code directory. Click on the File menu. Hover over Open Windows PowerShell. Then select Open Windows PowerShell as administrator. Now that PowerShell is running as administrator and pointed at our code directory, I can run the script like this. Python symbolic_link_setup.py. And that's it. Now, my folder, along with the Python scripts, is once again listed under DaVinci Resolve Workspace Scripts Comp. Once the link is created, I no longer need to keep the linking script in the project folder, so I'll delete it. I can always copy it back in the future when needed. Final notes. Please note that I've only tested this script on Windows. If you run into any issues, feel free to let me know. I'll do my best to help or update the script accordingly. And if, for some reason, the Python script doesn't work for you, I have a separate video explaining how to manually create the symbolic link. You'll find that link in the top right card and also in the comments. That said, I highly recommend trying this script. Once you get a hang of it, it becomes a very handy tool. Before I show you the actual content inside the code files, it is necessary to see the structure of the sample project I'm working with. Inside my Demo1 folder, our media content working directory, I have Audio contains the main audio track for the timeline. Clips contains sample video clips. Images currently empty. Main.add MP4, a sample video used later in our automation. This folder, Demo1, is what I refer to as the working directory or the main content directory for the current project. Additionally, I have another directory called Common Assets, a reusable library of media used across multiple projects. It contains BG_images, background images, intro_assets, intro audio, clips, and images with subfolders. Sound_effects, organize sound effects by category. Now, let's move on to the actual automation code. I'm using Visual Studio Code as my editor, so I'll right-click the folder and choose Open with Code. Of course, you can use any code editor you prefer. Inside the folder, I have these 4 files: MediaPool_setup.py, utils.py, config_windows.json, or config_linux_ or _macOS.json. I will show you what is inside these files step by step. In your case, you will need one of the configuration files, either config_windows.json or config_linux_ or _macOS.json, depending on your operating system. Now, let me explain what each file is containing. Let's begin with the config file. Open either config_windows.json if you're a Windows user, config_linux_ or _macOS.json if you're on Linux or macOS. What's inside the config? Now, the configuration file is simply a dictionary of paths and values that our Python code will reference. At first glance, it may seem a bit intimidating, but don't worry. The key thing to understand is that most of the settings in this file only need to be configured once. For future projects, you'll mostly just update a few values related to your current working directory. Let's walk through the key parts. Working directory, your main editing folder, example, demo1, main_audio_ path, and main_video_ path, the primary timeline media. Local_assets_ subfolder describes each subfolder inside your project, folder name, track index, and relevant keywords. Common_assets_ data contains structured data about reusable media folders, backgrounds, intros, sound effects, etc. There are a few more optional fields that will come in handy as we build more automation features later, but I've included them now so that future tutorials are easier to follow. Important: make sure to name the config file exactly as config_windows.json or config_linux_ or _macOS.json. And don't forget platform, Windows, or platform, Linux_ or _macOS. Should not be changed to anything else in the upcoming codes to work correctly. Now that we've set up the required configuration file, let's break down what is within the utils.py file. This is where all the heavy lifting happens behind the scenes. Let's begin with the module imports. We import 4 standard Python libraries. Platform, to detect the operating system. OS, for file and path handling. Sys, to access script arguments and runtime information. And JSON, for reading configuration files. Now let's look at the setup_project function. This function takes in a Resolve object, which is DaVinci Resolve scripting interface. It retrieves the current project using the project manager. If no project is open, it informs the user and exits early. Otherwise, it returns both the project and its associated media pool for further operations. Next, we have the load_platform_config function. This function identifies the operating system, Windows, Linux, or macOS. Based on that, it chooses the appropriate JSON configuration file, either config_windows.json or config_linux_ or _macOS.json. It then constructs a full path to the configuration file based on the current script's location. If the file doesn't exist, it raises an error. Next, it loads a JSON file and checks whether the platform listed inside the file matches the detected system. If there's a mismatch, it raises a clear error to avoid misconfiguration. Now for the main function. This function takes a path to your media folder and the media pool object. Its purpose is to mirror the media folder's directory structure directly into DaVinci Resolve's media pool. Within it, we define 2 helper functions. The first, checks if a folder exists under a parent folder. If it doesn't, it creates a new one using the add subfolder method. The second helper takes a nested path and ensures each subfolder is created one level at a time inside the media pool. This builds out the entire folder hierarchy as needed. We start the import by checking if the root folder for the media exists in the media pool. If not, we create it. Then we use os.walk to iterate through the entire media directory. For each file, we calculate the relative folder path and use create_folder_ structure to ensure that folder exists in the media pool. We then set the media pool's current folder and use import media to bring the file in. Every success or failure is logged for easy tracking. Finally, we reset the current folder in the media pool to its original location. These functions together provide a solid automated pipeline to load platform-aware configuration, ensure a project is active, and import media files with full folder structure directly into DaVinci Resolve's media pool. Now, let's jump to mediapool_setup.py file. This is the entry point of our automation script, and it's where all the pieces come together. Here's a quick breakdown of what's going on inside this main file. Let's start at the top. We begin by importing two modules, OS, used for file path handling, and utils, which refers to the utility module we built earlier. Now we move on to the main. This function coordinates the entire setup process. First, we load the platform-specific configuration by calling utils.load_platform_config. This gives us access to settings defined in a JSON file, such as folder paths and working directories. Next, we initialize the Resolve object. This is done using app-get-resolve, which gives us the scripting interface to control DaVinci Resolve. If Resolve fails to initialize, we print an error and stop the script. Assuming everything loads correctly, we extract the working directory from the configuration file. Then, we call utils to setup_project resolve to get both the current project and its associated media pool. If either of those fails to initialize, we call a helper function to print an error. Otherwise, we continue. Now comes the media import process. We begin by reading the list of local assets of folders from config file. If this list exists, we loop through each item. Each item provides a relative path, which we join with a working directory to create an absolute path. Then we call utils.import media with folder structure function, passing the full path and media pool. This mirrors the folder structure of each subfolder directly into media pool and imports the media files automatically. After handling local assets, we do the same for common asset folders. These are shared assets that aren't tied to a specific working directory. For each path in the list, we call the same import media with folder structure function to bring those files into the media pool as well. Once all folders are processed, we print a message to confirm that the setup is complete. Finally, we check if this script is being run as the main entry point. If it is, we call main to start the entire process. This script provides a clean and structured way to automatically set up your media pool using configuration files, making DaVinci Resolve project initialization faster, more reliable, and fully repeatable. Finally, we are ready to run our automation code from DaVinci Resolve. If everything went smoothly, your media pool should now be fully populated based on the structure and paths defined in your configuration file. If you run into any issues or errors, feel free to drop a comment below. I'll be happy to help. And if your code ran successfully, congratulations. You just laid the groundwork for automating DaVinci Resolve with Python. This is only the beginning. The foundation you're building here will make future automation workflows much easier and more powerful. Thanks again for watching. If you enjoyed this video, don't forget to like and subscribe. See you in the next video.